Hello everybody, Thy Lord Root here, and I decided I am going to start something rather new today. I'm going to try using something, or rather developing a new series which I've decided that I will call, Let's Code. And of course, this is sort of like Let's Play, except I imagine it might be either interesting or boring depending on I guess exactly how you want to go about things. It's basically just me gonna be messing around and coding various, various different topics. So yeah, I guess let me get started here. One thing I guess I do want to show y'all real quick is I want to show y'all a fantastic program for doing diagrams. It's called Dia. I've used this ever since undergrad, probably like 6 or 7 years ago. And we're going to be using this fairly frequently. If you don't recognize the window manager, that is probably because I'm using something a lot of people may not be familiar with. It's called Fluxbox. When I use Unix, I typically like to use it in preference to something like GNOME because I just really think it's a little bit easier to work with. So anyway, what is this episode about? Well, it's all about filters, and I guess just to give you an idea of what filters are and how they work, filters are basically these programs that that you can piece together to do nifty tasks, and this has a lot to do with way even before way even before Linux or even Windows, for that matter, because Windows does predate Linux by a good 6 years. That's the kernel, though. I mean the GNU operating system, I think, was started in the early 80s, but we're actually going to move back to a decade earlier to 1971 or so. And basically the idea is that, like, let me go back and show you real quick. I've tried making this terminal window a little bit, bigger, but let's say that I want to, I don't know, that maybe I want to do something really interesting with, a file of some kind. So let's go into usr.share. Look for, you know what, I'll use my X11 configuration for this. That seems like a good idea. Let's say that I want to see only the top few lines of my X11 configuration. And we can very easily do that. Except, I guess, because of the way that X11 has changed recently, it's not as easy to view. But let's just do etc x11 rgb.txt. So we've got all of these different colors here, right? And let's say we want to do something useful with it. Let's say we want to see how many colors are in that. Well, then we can use the WC for word count and pass in this L parameter, and we can see that there are 754 colors in there, maybe. We can make sure of that by viewing just the top by using the head command. So this is actually one less. This is 753 colors, right? And with that, we've got other things we could do. We could chain these things together. We could I don't know if I've bothered installing XXD on here yet. This is a new installation, but you can see we could get a hex dump of that first 25 lines or so. And so what we're doing is we're pipelining these things together, and this has to do with the way that processes in Unix are by convention created. So I won't go into the details here because there are two system calls that you have to usually make in order to create a process in a Unix operating system. But, it's worth pointing out that let's say this right here is our process. We'll call it P0. Then there are a few interesting things here. There is, maybe I'll go from over here instead, but there is, a stream coming in called our standard input, and two streams coming out, called standard output and standard error. And the ones we're largely focused on are, here we have the standard input, which in Unix is always 0. And we have our standard output here. I guess I should clarify what I mean here. Before C, I don't know if it was before C or not, to tell you the truth, but internally the kernel maintains these things called kernel or file descriptors. The confusing thing about this is that files are in Unix that they're not like necessarily files on disk. They could be, in this case, really anything. They could be TTY streams, which back in the old days before you had, these electronic terminals like the VT100, you actually had your computers hooked up to electric typewriters that the operating system would allow to print out to. And so this is an abstraction. And what we're basically doing here is when we pipe something together, then we're going to take this this other process here that we'll call P1, and we're going to hook this standard output from P0 into P1, and then set the set the standard output here for the output to the terminal or whatever. The shell manages all of this, needless to say. And so the question is, well, what about if we want to write our own? And it's fairly easy to do. All we really have to do is I'll just create a source directory. And we just have to write a program that works in terms of these streams. And so let's just create ourselves an infrastructure here. I'm going to create a program that removes all of the vowels from the input. So here we have, we'll just call this No Vowels. And here we're going to just use the C language in order to do this. C is pretty much the traditional Unix systems programming language. It's pretty good for applications programming too, which is what we're using it here for. And in fact, it was developed to facilitate the I guess the portability of the Unix kernel from another language called BCPL. it provides some amenities here. So I'm just going to create a new file here. We'll call this main.c. And I don't really want to turn this into a C tutorial. But in case you were wondering, I'm going to do something that you might find a little bit confusing. And as far as the C standard's concerned, there is two ways of specifying your entry point. You could have a null parameter list, or you can have this argc and argv parameter list that represents a number of arguments and the value of the arguments respectively. And so this is fairly straightforward. I guess we need to think about, first of all, what we're doing here. So I'm going to create a constant character array that is fairly easy to scan. You may or may not know that in C, arrays are essentially they're essentially these things that strings rather are arrays plus an ASCII null character on the end. So I'm gonna use both uppercase and lowercase because according to your computer they're different, which is not too terribly surprising, right? And I'm going to forego the command line arguments right now, because what I'm essentially going to do is I am just going to say I don't know, int buff, we'll just say this, char buff. We're going to have a single character buffer, and we're going to say while fread, I believe it's standard n. We're going to pass in our buffer, our single character buffer. This is where we're going to store it. And of course, this is a single character, so we have 1 here for our buffer size. So we're going to say this has to be greater than 0 because this is a blocking stream, and so our program will wait for input. And so really all we have to do is say, I believe it's putc. Maybe I'm thinking of puts. Or I'll even do it even easier to understand. I'll just say fwrite standard out our buffer in 1. And this should echo everything back out to us. So we're just going to return 0 to indicate success here, and we're going to do one more thing just in case things go wrong. Or not if they go wrong, but if, it's, even though C guarantees that the buffer will be flushed at the end of the program, we're going to flush that. So let's just compile our program with the GCC, and we're going to pass this in, what does it say, too few arguments. Let's see. It's been a while since I programmed at C. Okay, so I see what's going on here. Our buffer comes first. We have our buffer, 1, 1, because the size of our element is 1, and the size of our buffer in terms of elements is also 1. So let's just save that real quick. Too few arguments to fwrite. Let's see. I just had that up. So yeah, fwrite we need about the same for that. So yeah, we're just going to do that. And now I bet you this will work. Okay, so we have this, and if we run this, let's just do no vowels. You'll see it's hanging here. Let's just say hello world, and the console buffers my input until I hit enter. And then I can just, usually it flushes every time there's a new line character. That's kind of standard behavior, right? And if I want to end the stream, I'll just do Control D and it'll stop. But that's not what we want this to do. And so instead, we're going to say for each character, print out anything not a vowel, which is more useful. So we're going to have ourselves a shallow pointer to this, and the idea here is we'll say, well, buff is not equal, not and equals, not equal to, I guess, current, or the current value of current. We are going to increment that pointer. And I guess what we'll say here is, well, there's really two things we need to do here. We need to say if, well, current, rather, because we have that null terminator. And so we're going to say then if buff is not equal to current, to value of current when we dereference it, or if it's equal, then we'll continue through the loop. We'll just say here found a vowel, skipping. Okay, so now if we try this, when we say hello world, then what has happened here? It would seem as though we have a logic error of some kind. So that's rather strange. We'll just do printf d and then cur here, and then hopefully that'll get promoted up to a thingy. So we have hello world. Oh, that's weird. I wonder why it did not flush. Well, that is kind of bizarre. I bet you if we did Control D there, hopefully it will flush. Apparently not. We'll just do this. We'll do not a vowel C, and then we will do buff here. And so hello world, not a vowel. Okay, it looks like it's for some strange reason hanging here. Oh, we'll just do this. Printf have C. So yeah, oh yeah, okay, I see. I bet you what we want to do here is we want to put a label here. I will just call this fetch. And there's really a better way of handling this. In fact, let's not use the label. Let's do int emit instead, and we'll just say here char input. In fact, we'll just make this void, so that way you know, what we'll do here is we'll you know, just use this little wrapper function here, and so we'll just return instead of continue, and then if that's the case, then if we do make it all the way out here, then we'll just print everything out. So this reduces us down to you know, a fairly simple piece of code. I bet you that'll work now. Not buff, but input. And apparently I introduced a stray backtick into my program at some point. That's at line 9, which is somewhere or other around here. But I haven't, oh, there it is. Okay, so now, we do that. It probably helps to recompile the program first. That's very important. So you see the vowels are now excised. Well, what if we want to do something different? What if we just want the vowels instead? Well, that's pretty easy to do here. We just move this line up here instead, and when we do that, and we just get all the vowels in Hello World. That's fairly straightforward, and just to prove a point, C isn't the only language you can do this in. We'll also do, you don't have to use Nano for this. For writing Perl, it's a little bit quicker, in my opinion, but we could also write a Perl program, I guess. So we'll just say no vowels, And, we'll put in our shebang here. And we'll say, while my line equals, our standard input, line regex, A-E-I-O-U, A-E-I-O-U. We're going to do substitution on that, and we're going to make it global. And then we'll print line. That's fairly straightforward, right? And let's say hello world. And it does the same thing. Oh, pardon me. So this is essentially, this is essentially, in both cases, a finite state machine, to where we're controlling the output based on our state transitions here. So let's just bring up I don't know, I will use the not the UML, but there's the ER stuff, because it just seems to be easier to use. So okay, so we're in this this state called scan, and we will make that our starting state, and we have a similar thing, a similar state called emit. And what we're basically going to do here is, if we have, stuff in our character class, then we're going to, A-E-I-O-N-U, and we'll just assume that that covers lowercase as well. Then we are going to we're going to loop back into the scan and consume the next character. Otherwise, we are going to loop back here, and that we'll just say that transition can happen with any character, right? And so that's a fairly useful way of designing these things, and it brings me up into, I guess, another idea here. What if we want to design a program that transforms text into English? English being that sort of, I guess, that transliteration of, I guess, well, it's not really a transliteration, but it has to do with, with a lot of different Asian languages. Like, apparently not all of the phonemes exist in those languages. And so, the deal there, of course, is, that, things get kind of messed up because of the speaker who understandably does not, have English as a, doesn't know English as a first language. They could even be fluent in it. They just, there's some study that, showed that, by the time that, you reach the age of 5 or whatever, you lose, the ability to, to speak any phoneme that's not part of your core language, and I suspect that's the case here. And I mean, there are other grammatical rules that probably come into play as well. I don't know much about these languages just because, really, just because of the fact that it's not it's not a language that I wouldn't mind learning. For instance, Japanese or Mandarin or something like that, but it's just not something I've gotten around to doing. So and hopefully, by the way, this comes out on the screen. I'm hoping so. We're going to start with our boilerplate here, but we're going to do something a little bit different. I mean, there are a couple of things here that we need to think about. So we have this deal called filter, and it's going to be, it's going to be our function that we go in to determine whether or not to omit a character, right? So, in fact, I'll make this a little bit easier on myself. I'm going to well, first of all, I'm going to see. I think it's get C. I'm going to use get C instead. Or get care. And so we're going to do this. We're going to say while int C. Yeah, we'll make C. I don't think that works in C89. We're going to say this while buff is equal to get care is greater or equal, or is greater than -1, because 0 is a possibility here, come to think of it. Not in text because it's the null character, but we'll just say, filter, we'll cast this down to a char, and once we do that narrowing conversion, we'll do that, and then we'll just flush our standard output, and we'll pass in a character here. We'll call this buff. So R's and L's are tricky for these people, so we're going to say if C is equal to R, or we'll use a switch here. A switch makes good sense here. We'll say if C is equal to if our buffer is equal to R, and we'll just say buff is equal to R, and maybe I think there's put char too. Yeah, there's put char. We'll just say instead of put char, because or instead of using fwrite, we'll just say L. And similarly, we'll make this a macro here. We'll say define our substitution as x to y. So case x put char y break, not brack, but break. So we'll say here we'll substitute R with L, and we'll substitute maybe L with R, and we'll make the default case just, you know, omitting what is already there. This is a pretty good start, right? So we'll just save this thing here. Oh, yeah. Stalled the terminal there for a bit. We'll now say English. Really there's a couple more things we can do here. We need to do the lowercase variants, right? Now there's different ways that we could do this. We could use a lookup table, which could make sense. The switch method does in some way end up being sometimes implemented with a lookup table anyway, but let's say we have hello world, and now we have hello world, which is, you know, pretty cool. And we'll say maybe Eric Clapton can play some mean guitar. And of course it turns to Eric Clapton can play some mean guitar. I call that a pretty successful first stab. I mean, there are other things we could do here. Like, for instance, you know, maybe we want double L's or double R's to you know, maybe we want double R's to use a combination of the two, right? So let's say instead of double, let's name this, because double's a reserved word, we can't name it that, but what if we named it instead maybe preserve second, and we'll say Y or X or initial here or you know what, we'll just call this instead transform. So here's the deal, anything that already exists, we'll just say you know, put char initial or target, and then we'll put char we'll say here, you know, maybe initial is equal to get, or if, let's see, next equals get char if next is greater than -1, which is the termination condition for this. You know, really, we don't even need that. We can make these void because we're not returning anything. Then we can say put char next, so we don't care what it is. And so now whenever we write this, let's say hello world, then we have the same thing because I did not change this. I'll just change this to transform XY up here. And so we'll say hello world. Now we have hello world, which I think is a little bit more convincing. Another thing we could do here is we could say this. We could say that we want to drop articles. So what are some of our articles? We'll just call this well, we have our indefinite, so we're going to say drop indefinite char initial and the idea here is that we can do a couple of things here. In fact, we'll just say drop a we'll say drop a here and break, and we'll do the same with lowercase a, right? Yeah. So what we'll do here is we will now take this and we'll grab the next character and we'll say if next is equal to -1 and return because that's the end of the stream. Else if next is equal to n, and we'll say return a drop and we'll pass in initial there. And both of these cases return, so we're just going to put char initial, put char next, and that will cover us here. And we can do the same here to where say next is equal to get char. If next is equal to -1, then it's definitely and we don't want to omit anything. Else see, else if it's a space character, then we are going to treat it like punctuation, and we're going to say put char you know, our space. And finally we'll just, if that doesn't happen, then we'll say put char initial, put char in, and put char next. That'll do it for us, right? So let's now try an angry ox did attack a farmer, and it's dropped it and it's changed it to well, that's kind of weird. A apparently does not work. Oh, I know why. Because we forgot to add the other case. We'll just say put char let's say else if next is equal to space. We'll say put char and return. That's not entirely necessary. We don't need the return there. And now I bet if we say an angry ox did attack a farmer. Angry ox did attack farmer. I like that. But we do have a little bit of we can do some other things here, because as it turns out we need, or we could do Unguess as well. And that would prevent us from skipping that R. We'll just say here, if we don't return Unguess, next, and we need to pass in a string, so we'll do n. And so at this point, we can just leave a semicolon here, because this will turn into a no op, and we'll just say Unguess next standard input. And my thought is that, you know, when we do this, when we say an angry ox did attack a farmer, well, then what will probably happen is that we will get our weird output. So this sort of leads to an interesting way of seeing, you know, of approaching, you know, maybe even writing your own programming languages or other kinds of languages, because fundamentally what's going on with most of your programming languages is you do have a finite state machine, chopping these things up into what are called terminals. They're essentially words or whatever, and you have a program that will go through, and when it parses it, it's looking for certain patterns here. But that's just an example of how you might write a deal, you know, a simple filter like that, and we can even say man-p English, and let's just do man. We'll just say man. What is going on here? Whoa, man-p, you know what we'll say instead? Pager is equal to English, and we'll do man here. There's got to be a way to get this here. If we do man dash, I thought it was dash p. Catman. That's kind of interesting. Finding manual pages. I do want to do this because it is a little bit funny to read once you do this. But where is it? That is the question. It's not a prompt. That's not quite what I want to do. I don't know why it's behaving this way. Let's see. Why is it skipping my pager? I guess it's probably because... Okay. I'll do this. There we go. So now, now we have our, well, this is a little bit disconcerting as to why I can't, browse it normally, but you'll see that it just completely screws up the, manual. Does this have a use? No, not really, but, maybe, maybe if we do -p here, not -p, but maybe -p, maybe we can even wrap this in a script, maybe we'll call it, well, we'll leave that for next time. But anyway, this has been Dialord Root, and I hope that you have enjoyed this first episode of Let's Code.